A form of such discharger with a magnet which has been found convenient and adopted after some trials, in the conversion of direct currents particularly, is illustrated in Fig. 2. N, S are the pole pieces of a very strong magnet which is excited by a coil, C. The pole pieces are slotted for adjustment and can be fastened in any position by screws SSL. The discharge rods DD1, thinned down on the ends in order to allow a closer approach of the magnetic pole pieces, pass through the columns of brass BB1 and are fastened in position by screws S2S2. Springs RR1 and collar CC1 are slipped on the rods, the latter serving to set the points of the rods at a certain suitable distance by means of screws S3S3 and the former to draw the points apart. When it is desired to start the arc, one of the large rubber handles HH1 is tapped quickly with the hand, whereby the points of the rods are brought in contact but are instantly separated by the springs RR1. Such an arrangement has been found to be often necessary, namely in cases when the EMFF was not large enough to cause the discharge to break through the gap, and also when it was desirable to avoid short-circuiting of the generator by the metallic contact of the rods. The rapidity of the interruptions of the current with a magnet depends on the intensity of the magnetic field and on the potential difference at the end of the arc. The interruptions are generally in such quick succession as to produce a musical sound. Years ago, it was observed that when a powerful induction coil is discharged between the poles of a strong magnet, the discharge produces a loud noise not unlike a small pistol shot. It was vaguely stated that the spark was intensified by the presence of the magnetic field. It is now clear that the discharge current, flowing for some time, was interrupted a great number of times by the magnet, thus producing the sound. The phenomenon is especially marked when the field circuit of a large magnet or dynamo is broken in a powerful magnetic field.